Okay, then we'll move on. The second important reason for selecting local provenance plants is to maintain ecological relationships between the plants you're putting in the ground and the surrounding flora and fauna. Well, I'll pass it over to the panel first, and then we'll see what questions have not already been answered. So does anybody on the panel wish to talk about the idea of planting local provenance plants in order to have compatibility with the existing flora and fauna?
Yeah, I can talk a bit about this. So this is a concern that stems mainly from the Northern Hemisphere literature. So there are quite a number of studies that show if you move a plant species from Spain, for example, to England, what can sometimes happen is it will flower at the time it's meant to in Spain and not at the time in England, when the actual pollinator might be coming out of hibernation or emerging from its cocoon or whatever. So you get this dysfunction between the pollinator being available and the flowering happening. There's limited, if any, evidence for that occurring that I can think of in Australia in terms of plants.
Is it one grass?
One, yeah.
I was going to say, we've got starting a collection of Ajuga australis that we're growing in the glass house at the moment, and our specimens from Atherton are actually about to flower now, whereas the ones from Mount Buffalo and other regions in Victoria are still forming buds, we think, but you can't actually see the inflorescences. So, you know, that's maybe a carryover effect because they haven't been grown in the same conditions for very long, but we think that it may actually be a genetic effect based on the environments that they have evolved in.
Yeah, people have done some fairly big experiments on this. So the question is, as Liz said, is it genetic, or what we call, is it plastic? If it's plastic, it means that you may have a difference in flowering time in a particular location compared to another location. But when you move those plants to the same location, the flowering time converges. So that's what we call a plastic response. It's not genetically based. And in a lot of cases, we have situations where flowering time and diapause, hibernation, those sorts of things are actually plastically determined. There's a plastic response, not a genetic response. So apologies for the jargon, but it's a very commonly used jargon that we use in this context. And as Liz said, there are some situations where it is actually genetic, and then it can be pretty important. And at the moment, we have some experimental data that says plastic is often important. We have some experimental data that says sometimes genetic is important. And it's really a situation where I think what we have to do is accumulate knowledge. And I think at the moment we are dealing with imperfect knowledge, but we are collating it as much as we can and as fast as we can.
And I'm going to throw up a plastic plant. We could hardly have a conference about plants, and the lighting is terrible here, so the loss of that light that was on is now a bit of a problem. These are plastic plants, but they're not artificial, they are real plants. This is a species of wallaby grass, Ritidosperma alpicola, the crag wallaby grass. These plants in full flower, as you can see them there, started their life as seeds on plants at Mount Nels on the Bogong High Plains. The parents are still under the snow and spend all winter under the snow. These plants I've grown from seeds, and they're about 3.5 years old and flowering beautifully at the moment, even though had they remained in situ on Mount Nels, they would be under the snow and they would be flowering in December, January, mostly January. So that's an example of a plastic response. This is a species which can adapt to the conditions where they're growing. No genetics involved there, it's just that many species are plastic in that way. So I just thought I'd throw that one in. I was going to use it later. Now, do we have any other responses from the panel? What about from...
I can just give one interesting example of work that we've done on our Flora emblem, the Waratah. And that's a situation where the plant itself flowers in response to temperature. So it needs X amount of days at about 20 degrees to flower. And so, as a consequence, flowering time on the coast is very different from flowering time up in the Blue Mountains. And the populations are quite differentiated from a genetic point of view because there is no contact between those populations. But is there? Realistically, when we started to look across the entire distribution of the species, we found, as you would expect, that there are intermediate populations where there is a little bit of overlap with the mountains and a little bit of overlap with the coast, where the two genetic groups cross, admix naturally. And as temperature, and I'm not talking about anthropogenic climate change here, I'm talking about the natural cycle, temperatural cycles from glacial to non-glacial. As the temperature changes, this genetic separation increases and decreases. So now we have an increased amount of exchange between those populations, completely natural. In different climatic conditions, those populations are completely separated. So what I'm trying to say here is that those kind of processes of mixing types that respond to different climate conditions are, in some cases, fairly natural.